Okay, so we really want to talk about radians. And again, this is a way to measure central angles of a circle again, right? So we're still doing trigonometry. We're still talking about the unit circle. We just want a different way to measure this central angle here. Okay, so another unit of measure for an angle is called a radian. Right? It's based on the word radius, as we just saw in the activity, right? It's the number. We have this connection between the radius of a circle and the number of lengths that it would take to go around that circle. Now, as most of you have discovered, the circumference formula tells us that the circumference of a circle is 2 pi r, correct? It's 2 pi radians. And we know that 2 pi is approximately 6.28. So most of you, right, I saw some 6 1/4, I saw some 6 1/3, you know, we saw some 6 1/2, we saw some 6. They're all pretty close there because you didn't have the best materials to work with on that activity, right? And it's hard to measure straight lengths along a curve. Now, probably if you're measuring a solid circle and you had like a piece of tape, you could get more accurate, but this is that ratio. So a picture that really describes what a radian looks like, or what it is doing, is this central angle here we define as 1 radian, okay? And this could be any size circle, right? Any size circle. But the distance, the length of the arc that's swept out by the angle, right? Because we think of the angle as having initial side, terminal side. The amount of arc swept out here is equal to the length of 1 radius. Right? That is when the central angle would be 1 radian. Okay, does that seem? That's what it's talking about. Now, we want to talk about how many degrees are in 1 radian just to kind of help us. But it ends up, it's not going to be a very nice number because you're working with pi, which is irrational, and we're going to get a lot of decimals. So something that we're going to see is as we work with radian measure, we love to have pi in there as a number. So we'll see measures like 2 pi over 3 or 7 pi over 4. We like that. Now, if you're putting it in degrees, you just cash out the pi for 3.14. You just hit the pi button and let the calculator simplify it. You would never say like 6 pi degrees. That's kind of different, right? Not how we tend to measure that. So now the next question here is how many radians are in a complete circle? Well, that's what we just looked at. So we had 3 different size circles, correct? That we worked with. And as we worked with those, we saw that all of them, it was about 6 1/3 or 6 1/4 radiuses or radii to get completely around the circle. Right? Now, we've then found that it was actually 2 pi was that number. Right? There were 2 pi radii to go around your circle, whether it was a little one, whether it's a big one, whether you're talking about like super tiny things or super large things. It's always going to be that same number. But the way we like to do conversions here, as this starts on your paper a little bit, is we know that a complete revolution, if we take an angle and it goes completely around, right? We just said that in radians, that would be 2 pi radians. Right? That's how many radians are in a complete circle. And rad is usually how we abbreviate radians. Now, because this angle is based upon a length and another length, radian we just put there as a convenience. It's not actually a unit. It's just sort of to remind us that, hey, we're in radian mode. So if you're ever doing math and you need to get rid of it, you can just drop it off. So if you have radian inches per minute, doesn't make much sense, but you might say inches per minute. You can just drop the radians off. Degrees you can never drop off. If there's a degree, you have to account for it. You have to do dimensional analysis to get rid of that, however the case might be. So we know that if you have a circle, an angle that opens and does a full revolution, that's 2 pi radians. That's also equal to, in degrees, 360 degrees. Okay, so now our conversion factor that we like to use is the first one listed there. For conversions, which we'll get more practice on these, I tend to use pi radians equals 180 degrees. You just take this and just divide them both by 2. So nothing too exciting there. Right? Makes it nice. So how many radians do you think there are in 90 degrees? Well, if this is, you can divide both sides by 2. So we get that there's pi over 2 radians in 90 degrees. And we write it as pi over 2. You rarely ever see it written as 1/2 times pi. It's always going to be pi over 2. I think the other one you're asked about on your worksheet is 270 degrees. Well, that's 3 times 90, isn't it? So that's 3 times pi over 2, which is 3 pi over 2 radians. But let's take a minute to just do some quick conversions here, and then we're just going to talk about some patterns at the bottom of your worksheet, and then we'll go from there. So, in terms of these conversions, again, our standard fact is that we have pi radians equals 180 degrees. Okay, so thinking back, we're going to use this fact that pi radians equals 180 degrees, and we're going to use that to help us do conversions. So there's a bunch of angles we talked about in degrees that we see a lot. So maybe like, I don't know, like 60 degrees, right? That's one that we see a bunch, or 30 degrees. So let's convert 60 degrees to radian measure. So to do this, we're going to take 60 degrees, and we're going to use a conversion factor. So we're either going to use 180 degrees over pi radians, or pi radians over 180 degrees. You're going to make a fraction out of it. Now we want degrees to go away, and degrees are currently in the numerator. So we want, for our conversion factor, we want degrees in the denominator. So we'll get pi radians over 180 degrees. Now the degrees cancel. We said we want to leave pi in there. 60 divided by 180 is just 1/3, correct? So this is going to give us, and if you have a calculator available, you could even have your calculator reduce 60 over 180, but that one should be pretty automatic, I hope. So that would be pi over 3 radians. Right? That's going to be one of our common ones. And we'll look at the other ones here in a second. Now the other way is how to convert a radian into a degree. And an interesting one to do, and I think it was on your little activity there, is how many degrees are there in 1 radian? So if you might have calculated that, you might have taken 360 and divided it by 2 pi, right? And that would give you the number of degrees in 1 radian. But let's go ahead and convert 1 radian to degrees. So we have 1 radian. Now we know that we need radians to go away, correct? They need to cancel out. So we're going to multiply by 180 degrees over pi radians. Now the radians will cancel. And then we're left with 180 divided by pi degrees, but we don't want that, right? We said with degrees we don't want to use pi. So we're just going to go ahead and use our calculators. And you're going to actually want to use the pi button on your calculator because it'll keep a lot more decimal places. You don't really want to round it. And we get 57.3 degrees. So 1 radian, which looks like it, you know, I tried to make it about 57 here, right? 1 radian, the central angle is 57.3 degrees if you're measured in degrees, or 1 radian if it's measured in radian measurement. So again, even though we're talking about a radius of a circle and an arc length of a circle, radian is still a way to measure an angle, correct? It's a way to measure an angle based upon the radius and the arc length. And we'll deal more with that formula later. Questions with this? So we'll do some conversions here in the next few days. But the last thing I want to look at here, because we're going to have to build a unit circle again, and we're going to want to talk about it using radians. On the back of the paper I gave you is a blank unit circle, okay? But instead of just filling it in what I think is going to be more valuable is I actually have 4 unit circles here. We're going to look at some particular points and look at their radian value and really look for some patterns here. Right? Because if we can put these patterns together, it's actually easier to evaluate these things in radians, a lot of angles, trig functions, sine, cosine, tangent, etc. in radians, once you learn the patterns, than it is to think about degrees. Because you don't have to do any calculations. You just kind of look at it and you'll know the value and decide whether it's positive or negative, and then you'll go from there. Okay, so the first one we'd want to look at are the quadrantial angles, or the angles between the quadrants. So we know that a 0-degree angle is the same as a 0 radian angle, and that would be the point 1, 0. We said that 90 degrees is the same as pi over 2 radians, and that's the point 0, 1. Out here is pi radians, and this is the point negative 1, 0. And then here is 3 pi over 2 radians, and that would be 0, negative 1. Right, so again, it's your 0, pi over 2, pi, 3 pi over 2. When we're calculating trig ratios in radians, a lot of times for these it's just nice to think about the cosine is the x value, the sine is the y value, y over x is the tangent, and you can build it that way, versus maybe some of the other translation aspects. Okay, now, the next one we want to think about on the unit circle is a 30-degree angle, right? So, if we convert it, 30 degrees times pi over 180 is going to give us pi over 6 radians. Now, here you notice I didn't even bother writing radians. If it's pi over 6 and there's no unit listed, you know that it's in radians because that's the default measurement, right? A degree has to have a degree on it. A radian does not have to have an RAD after it. Okay, I'll try to put them on here just for, for simple to help us here. But let's look at the 30-degree or the pi over 6 radian. These are the ones going to be just like 30 degrees. These are the ones that are all closest to the x-axis. Okay? And if we work this out, we'll get pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Do you notice they're all over 6? You notice they're all reduced, correct? Okay, good. And then they're all forms of the point radical 3 over 2, 1/2. Right? You can write it all the places if you want, but we just know they're going to have the same numbers in the same place, but the positives and negatives will be different. Just like we saw with 30, 150, 210, and 330. Right? To me, it's a lot easier to see that these are all connected because they're all over 6 than to think about the actual degree measures, which are kind of arbitrary looking, right? You have to measure them off the x-axis. So the next thing we want to look at is a 45-degree angle. So times pi over 180, that's pi over 4 radians. So that would be here and here. Okay, now what we're going to see is all of these are going to have an over 4 with a pi on top. We're going to get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All these points will be some form of radical 2 over 2, radical 2 over 2. Notice again, they're all over 4. They're all completely reduced. And then lastly would be the 60-degree angles. So times pi over 180, I think we did this one already. That's pi over 3 radians. So then we have here, here. With these, it's going to be pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, and they're all some form of the point 1/2 radical 3 over 2. Now, the thing that will confuse people, it's been confusing people for a long time, is that we need to remember that pi over 6 is a smaller number than pi over 3 because of how fractions work. People are generally not good at that, right? The A&W restaurants came out with a 1/3 of a pound hamburger because they wanted to compete with McDonald's quarter pounder, and it's actually bigger. People didn't they didn't sell well, and they think the reason was is that most people thought that a quarter pounder was bigger than a 1/3 of a pound. So, yeah, that's where we're at. So, okay. But anyways, there's a bunch of patterns though. Do we see how all these things that are basically like versions of the 30-degree or a 30-degree reference angle, these are all over 6? Okay. A pi over 4 reference angle or a 45-degree reference angle, these are all over 4. Here, a 60-degree reference angle or a pi over 3 reference angle, these are all over 3. And even another pattern to help with that, so what we can see is if we see it's over 3, we know it's going to be some version of this point. If we see it's reduced and has a pi on top, over 4, it's going to be some version of this point. If it's over 6 and reduced with a pi on top, it's going to be some version of this point, meaning the pluses or minuses will change at that point. So the last piece with this is how to tell which quadrant you're in. If you notice, everything in the first quadrant, it's always 1 pi over the number, isn't it? In the second quadrant, it's 2 over 3, 3 over 4, 5 over 6. Notice the numerator is 1 less than the denominator. In the third quadrant, 7 over 6, 5 over 4, 4 over 3. The numerator is 1 bigger than the denominator. Fourth quadrant, 5 over 3, 7 over 4, 11 over 6. Everybody see that pattern? Yes?
It's 1 less than double.
It's 1 less than double. Yes, so this was, you double 6, you get 12. You take 1 away, you got 11. All right. You double 4, you get 8. Take 1 away, you get 7. Double 3, you get 6. Take 1 away. So that's a way. So this way, we should be able to pretty quickly identify the basic starting point, right? The coordinate. And then from that, we use which quadrant it's in based upon the numerator compared to the denominator, and that'll tell us if, all students take calculus, the different signs of the trig functions, or if we want to use the x and the y. We know that, in the second quadrant, that x will be negative and y will be positive, just based upon that location. And we'll work a lot more with these over the course of the next few days.